Thank you. And thank you for attending this session rather than the NSA next door. So it's a much better session, don't worry. So, as I say, I'm a cloud security architect, and for the next 6 weeks I will be with IBM, and then I'll be retiring. But I've got some other things I'm going to do, and I'll talk through that a bit later. So we're going to talk about moving security architecture from art to engineering, and somebody did a presentation yesterday and described, I guess, as an architect they enjoyed being the artist. But really we need to get to the point where architecture is less art and making it up as we go along, and making and more about engineering. So what I'm going to do today is to talk about a sequence of artifacts and techniques that you can use together as an architect to develop security into a solution. And the industry says, oh, well, it's security architecture. Think of it as architectural thinking for security, because architecture is not security in itself. It's about adding a non-functional requirement to a solution. So this work started actually 25 years ago, but it got resurrected about 6 years ago. And so I'm going to take you through the work that we've been doing with 2 universities and internally within IBM. And we've ended up with training over 1,000 learners and students so far. And when I came last year, everybody said, well, where can I learn more about it? Well, I'm going to tell you about how you can learn more about it so you can actually practice it in your own organizations. There was 2 interesting points made in the on Monday. So Kevin Mandia pointed out that some challenge areas. One of them was secure by design. Now, secure by design is targeted in some cases at products, but many of us deal in systems or systems of systems, so we deal in a lot more complexity. And the way in which it's described is maybe it's a principle, but you don't actually have a really clear set of activities or set of techniques or artifacts that you use with it. So that brings a challenge to, how do we get secure by design into an organization? And the second thing was there was a comment to say that in terms of CISOs, that one of the 3 key skills, one of them was being an architect, so being able to communicate effectively security. And so we're going to talk about communication. So, and I always talk about, when I'm teaching this, being an architect is communicating the overall solution for the system. So the diagrams, there's the usual thing, but also the diagrams in here are all from the book that we put together, and I'll talk more about that later. So typical designs as an architect and what I see, we tend to see security documentation comes in different formats. And you have to go and you have to interpret those formats within that documentation, because they're all inconsistent. There isn't a standard way of presenting it. Those diagrams, unfortunately, with cloud, seem to be focused on the latest, the branding of the latest cloud, and the implementation, but forgets about the thing that we really care about as security professionals, which is protecting the data. And so thinking about that. The other thing we focus on, unfortunately, it's a bit of a joke that we focus on demonstrating non-compliance. And then because we're non-compliant, we add more compliance into our organization. So if we get our solutions right and we clearly communicate those solutions, then we shouldn't need the level of compliance that we have today. So really, I'm trying to go and communicate that, communicating from the beginning is a very important step in the process. And decisions are made based on personal experience, and somehow we need to get to the point where it's made on best industry practice and so on. So I'm going to talk about the needs. Really, we need some practices founded on consistent techniques and artifacts. and we need them to scale. So we need them to scale to systems and systems of systems. And we need to focus on really business risk, which is about the data and the availability of the processes. And we need, rather than just the compliance within a system. So that's what we're going to talk about today. In terms of the agenda, I'm going to go through some terminology because even listening to sessions this week, what is architecture is a very important thing to understand. And we're going to talk about design and the other terminology that we use in the industry, so to set the rest of the session. Then I'm going to go and give you a brief overview of how we're going to turn it from art into engineering. So we're going to make it more scientific. And the new section that I didn't talk about last year is establishing the context. So, and you may think it's okay, it's a policy or something very simple. But when you reflect on it, there is a lot of things that we need to go and put into the system, at least get the requirements and decisions from. And then I'm going to talk us through the actual architectural thinking process. I'm going to do a very simple set of layers, trying to compress a 3-day course into 40 minutes. Obviously, I'm going to have to be very brief. There is some more detail on, if you look at the session I did last year, in some of that. So, understanding terminology. When we go through the cycle of a system, from a business perspective, we often start with design thinking, and we have some consulting processes and other things. So we're trying to gather the business requirements. And you may say, well, why am I talking about business? Because security is not a thing in it, a thing you need by itself. Security is part of a business application, a part of business processes. And a security architect is there to support the architects, the system architects, the application architects, who should understand what I'm going to talk about today. So what I talk about today and is really for all architects who are putting together a system. Then you go through the architectural thinking process, and often that gets missed because somebody then just draws a cloud architecture diagram and implements it. But what they haven't done is thought about, well, what's the business aspects and how that data is processed, is transported within a system, and we'll come back to that. And then finally, we need to think about the operational part of it. How do I actually continue to secure the system? And that's the thinking that also needs to be part of the architectural thinking process. So the first thing is, what is design and what is architecture? So there's a nice quote that Grady Booch, he is sort of one of the founders of object-oriented thinking. He's an IBM fellow. And what he says is all architecture is design, but not all design is architecture. Architecture represents the set of significant design decisions that shape the form and function of a system, where significant is measured by the cost of change. So, and there was an example yesterday, I think, of an architectural decision. So, if I'm going to, I decide that actually I want to go and block a particular file. If that decision is simply I'm just going to go and configure something that I have exists already, it's not an architectural decision, it's a design decision, it's the next level down, it's something configuration system. If I decide that I've got to add a new component into the system that has an additional cost, that has additional change, you've got to change the architecture of the system, that is an architectural decision because it has an impact on the overall system, and that needs a set of stakeholders together to make that decision. So that's what architecture is about. It's about making those significant architectural decisions in the system. And you need a way of communicating those decisions. And when somebody says, well, what's the minimum I need to do as an architect? The answer is, you make architectural decisions. And everything else you do is simply a way of communicating those architectural decisions. So The other thing that sort of is, the buzzword, and that comes in and out, secure by design. But where does that fit into this, this cycle? Well, secure by design really started out in terms of thinking, and I think more than 50 years ago. But when IBM built MVS, they had a security team. They put that was inherent in the design of the operating system, and that's developed over the years with some listings on engineering, trustworthy, secure systems, and the recent focus from CISA and all the other national security organizations with secure by design. But that's focused on products. That hasn't looked at the bigger set of, well, how do I combine those products together? And how do I combine into systems? And how do I integrate systems together? And that's where architecture comes in. And yes, there has been developed. So the UK government has been said, okay, here's a long list of activities I need to do for security design. But what they haven't said, and I'm sure CISA is going to do the same thing, what they haven't said is, well, what are the techniques, what are the artifacts I need to go and use? So every government department in the UK will do it differently because they'll come up with their own interpretation, which is costly. They're learning it as they go along, which is where we need a standard set of techniques. And if you look at the definition of architecture and engineering, you'll see that engineering aims for technical optimization, architecting for client satisfaction. So engineering is more of a science and architecting is more of an art. And so we need to try and change that from being an art to push it more into the engineering, more of a science. And we can do that by having a standard way of describing things and a standard set of techniques. So how are we going to do that? So I'm going to talk about technique that set of techniques that we've developed to structure the way that we think in terms of putting a system together. We need a common language. So if we all come up with different diagrams, which mean different things, then we can't share them and communicate effectively. We need a standard set of practices, not just a list of activities. A list of activities is great, but if it says design this system, how do I design the system? We all come up with our own way of doing it. And we need to think about it not just in silos. So we have all these buzzwords. We have secure by design, zero trust, we have compliance, we have all these things. And the challenge is we try to deal with them individually when we need to deal with them within an integrated solution. So, and the final thing is we need to make it scale, because we're not dealing with products, we're dealing with systems and systems and systems. We're dealing with complex solutions. So what we did was we put together 4 areas. We started with data-centric security, and that was the focus. Even when you're a consultant, you build up an information asset register, you're thinking about data. Well, that's the foundation of what we're trying to go and protect. So we need that as part of our architectural thinking method. We need secure by design, because as a principle, we need to go and use that. And really, as part of secure by design, it'll always point to threat modeling. So threat modeling is part of that. So we need to encompass that. And we need to bring in the secure zero trust principles. And I don't mean a zero trust network architecture that's a product. I mean thinking about the principles behind zero trust. And it's not necessarily the list of solutions. It's the thinking that you need to go and follow as part of that process. And around that, we need compliance, because we all need to demonstrate compliance. So what we're trying to do is integrate those 4 domains together. And the way we've done that is by creating a set of artifacts. And you're not going to read that unless you've downloaded it. So I'm going to go and do something a bit smaller. So you can go and look at it in your own time. So what we've done is, rather than said, here's this great big document you're going to produce, because you don't need the document many times. You need the actual pictures, you need the in tables, the techniques. that you can go and select from those depending on the context of what you're designing or architecting. So we start with the enterprise context, and I'll talk a bit more about that. So those are the internal and the external things that influence the design you're putting together. A set of requirements, functional and non-functional. So as a security architect, you're also a software architect. You're also an architect that thinks about resilience. You think about all those things. And so you need to go and gather those sorts of requirements together and document those. Then we use the architecture. How do we describe the solution? And that's the area I'm going to focus on a little bit and show you the decomposition. And we also have to think about the operation. So not as an afterthought, it should be built into the system. And I'll show you how you build that into the architecture as you go through that thinking. And then we have a little bit about governance. Well, down there goes the RAID log and the architectural decision register. And the assurance, which includes the testing to go and demonstrate that you have delivered the controls that you specified. So we build up these artifacts, and I'm just going to go and do a few of them during this session, but you can go and have a read of that later. So the first thing we need to do is establish the context. We need to understand what things are influencing the design that we're trying to put together. So, and along the top we had this establish the context, and we have a set of different artifacts, different bits of information that we gather that influence the design of our system. We have external things like our laws and regulations, but we also have other things like, the vulnerabilities are external, the threat landscape, but consumer expectations. Consumers expect us to go and protect their data. They expect privacy. So those are some of the external contexts we need to build into our solutions. And on the right, we've got all the things that we built internally now, the policies and processes, and standards and practices that come with security should encompass all the external things, but often they don't. And then there are other things that influence us, like the current IT environment. How are we going to go and run? What's the overall architecture for how we're going to run our security control plane, and so on. So I'm not going to go into all of those, but what I'm going to do is I'm going to talk about enterprise architecture, because the enterprise architecture is going to guide the controls about how you're going to deliver those within the organization, and how what sort of controls you're going to have within your systems. And so one of the challenges in our industry is that we have lots of enterprise architectures, but many of them are produced by solution providers, and they will adopt the perspective of the solutions they deliver. So what I did was I took about 20 different models and produced a reference architecture that we use that gives us a broad coverage of the domains along the top. And these are all familiar to you: identity and access network, application data, endpoint, and detect and response, and they also align with NIST cybersecurity framework and so on. So those are the domains. But if we decided we were going to use Protect from cybersecurity framework, we would decide we need to decompose it, and that's effectively what we've done here. And so within those domains, there is a set of categories, and then there are services within those. And I use the word service, like threat management, vulnerability management, because we're not dealing just with a process, we're dealing with process, people, and technology. So it's something that we deliver as a service. So we use that as our starting point. And on the left-hand side, you've got the GRC type stuff, and on the right-hand side, supporting services, because we can't do security without problem change and incident management, the basic service management processes. So we're trying to go and also reflect that those are also needed. Now, you'll probably come up with a slightly different version of this. I'm sure everybody will come up with their own, but it's a good starting point if you want to go and build something. And it's quite useful because it can become a heat map, and it's a very useful tool within your own organization to go and say, well, these are the areas that are focused for this sort of application, or this is the actual maturity of this particular area. So it's also a communication mechanism as well. And some of my colleagues then overlay regulations. So they say, okay, 5 or 10 of these blocks are appropriate to this regulation, and therefore they describe the particular services or controls within those blocks. So they use it like that. So it's also useful as a checklist for coverage. So sometimes, yes, you can do things systematically, but sometimes you want to do things roughly to start with, and so therefore it's a good thing as a checklist as well. So that's what we've used internally. So that's our enterprise architecture. That is part of our internal context that guides the solution we're going to develop. So how does architectural thinking for security work? I'm just going to go and use the bit that is the architecture, the middle bit block. And the way that we do that we teach this, and the best way of doing it is to go and create a case study. So we created a case study, and that case study has payments, it has external directories, it has all the other things that, the basic things that you would have in quite a few different systems to go and teach the concepts. And you'll see on this picture that this is what's called an architecture overview diagram. It doesn't have a format. It's designed to you at a business level to express, at least to be able to communicate the system you're trying to go and build. So in this case, I picked a scheme where you drive into the city, if you have a car that's dirty, then you get charged for it. And if you have an EV, then you don't get charged. So that's being rolled out across some of the UK cities at the moment. I don't know if you have similar in the US. So we use that as a starting point. The principle behind what we're trying to go and do is about data. We start with an actor, in this case the shopper. I've got another scenario, a shopper, and they want to go and buy something. We know that it accesses a system within an organization, and within that system we have functional components. We know that the flow goes through those functional components. At some point, the data might get decrypted, it might get stored, it might get processed, and it flows out the other side and goes to some other payment system and back in as part of when they process the order, and then for the delivery system and back the response to shopper. So the principles behind what we're trying to go and look at is to look at the actors in the system, the flows between those actors through the system and out the other side and back. There are a couple of other flows that you need to think about. One is thinking about things, events that are also triggered by time or some alerts or other things. And the other area perhaps you want to think about is the flows of the threat actor against the system. But really what we're trying to do is think about those flows, because those flows, those transaction flows contain data, and those are the flows that we need to protect. We're not protecting using a compliance checklist, we're protecting the thing that we really need to protect, which is the data, and focusing on that. So that's the principle behind what we're trying to go and do. And the architecture, we build it in layers. We're going to start with the system context diagram. I'll explain what that is in a moment. That's the top level, which describes the boundaries of the system and the actors that interact with it. The next level is the functionality of the application, the functional components of the application. We do that in the component architecture diagram. So what I did was, there are names in the industry for different, you could call this a component model or various other things. In the C3 model, C4 model, they call it other things. But what I tried to do was to sort of normalize the names so that you can go and use them and overlay them into your own methods that you use in your own organization. Cloud architecture diagram, that normally applies to a diagram that each cloud provider seems to go and create with their own nice colored formats and things and styles. And shared responsibility diagram, and I'm going to talk about that because that's the biggest challenge to our industry. Is we used to go and deal with systems that sat on a mainframe or a Windows server, and everything happened within that. But now we have systems that actually span on-premise, multiple clouds. They sit on multiple technology platforms. They're containerized, they're on servers, they're in appliances, and so on. They're in services within cloud. And so now we have a collection of different environments. And I'll talk more about that. So at the simplest level, we have 3 layers. I've missed one out in this picture because it looks better this way. So system context. The first diagram is defining the boundary of your system, the actors that interact with that system, and therefore they must have particular use cases, and they must process data. So that's the very first thing. When you get an architect, the first thing they do is try to go and describe what's inside that box, inside that circle. Forget what's inside that circle. Just think about what is the interaction. That's your first diagram. And I will show you some real ones in a moment. Next thing is, okay, now I understand the boundaries of the system. I know what interacts with it. I want to understand the functional components of the architecture. Forget how it's implemented. And it's very easy to go and say, oh, okay, I'm going to, it's going to be this component sitting on a server or whatever. Forget this is the functional bits, and this is the application. This is what the application architects do. And as a security architect, we should still think about, we are an application architect. If I think about identity and access management, it's an identity and access management application. It still has a front end, it still has a database, it has some business logic. It's just an application. It's a special application, but it's an application. So think about the functionality and ignore how it's implemented. And then finally, down the bottom, we've got the deployment architecture, which is how are we going to go and implement those functional components onto that infrastructure. And often you'll see that drawn up as cloud architecture diagrams, or you might find some internal network diagrams, but often they're too detailed for you to go and actually communicate what you're doing. So we've got those 3 layers. First layer is a system context diagram. Very simple. It just says it's an online store, and these are the set of actors. And I'm sure there are missing actors out of here. We have 2 types of actors. We have human actors on left and top, and we have system actors on the bottom right. So those are the sorts of actors that communicate with our system. And I can see various other actors there's lots of actors that are missing from here. So for example, I've just got system admin. Well, where's the compliance team? Well, they need access to the system. Where is, we got internal accounting, this is an online store. Where's the payments? So that's a system actor that should go on there. I've got no payments on here. And so on. So you start to go and build up your list of actors, the interfaces that you'll need to your system, because those are the interfaces that you'll need to secure. And over time, you then you get an agreement, and against each of those actors, you have a set of use cases. So those are the things that communicate with the system. So now you've got that drawn. Okay, now I'll let you go and look inside the system. And the system here is actually, it looks like something like the UML models, but it's got functional components with interfaces and flows. So on the left-hand side, we have the actors. It hasn't got the same set of actors, but it's got some actors down the left-hand side. It's got some social media. We didn't have it on the previous one. We've got our typical 3-layer architecture, but we've also got some integration. And those little boxes with little squares or little rectangles at the top left are subsystems. They are groups of functional components, but they don't actually describe the flow or the interaction of those components. And then we have components within them. And then we do our threat modeling, our first threat modeling, because this gives us a starting point at the application level. And I'm not going to, this is a very simple way of threat modeling. So the point of what we're trying to go and teach is that you need to do your threat modeling, but you may actually use different techniques in your own organization. You may use different tools. And as you go through this, you'll come to the conclusion, well, and I think there's a comment made yesterday, do you use spreadsheets for your threat modeling? And then the whole thing sort of dies because everybody doesn't like to maintain spreadsheets. So I think I have this view that really tooling is needed to go and do a lot of this stuff if we're going to make it work. So we teach them threat modeling, and we now have functional components, but those functional components need to be deployed onto some infrastructure. And our infrastructure doesn't look like a data center anymore. It doesn't look about one cloud. We end up with on-premises, cloud, we end up with SaaS applications that we're integrating into it. And so we've got to decide where those functional components are placed within our system. So we build up this stack diagram, or whatever you like to call it, shared responsibility, because there's also, you can build onto that. I gave the simplified version, but you can also build into this shared responsibilities. You can show, well, who's responsible for each of those technology platforms. Because each of those technology platforms will actually have different policies that apply depending on the layer you are within that stack. So if I go to AWS, I know that the things that they run are run according to their policy. And all I can do is have a contract with them. I can't, most people can't do an audit. There are some people that can. But in most cases, you just have a contract with them, and they commit, they put their hands on their heart and say, yeah, I'm going to go and do it. And you have to believe them. But they're also, each is different, and the responsibilities are different depending on whether I'm using a server, I'm using a PaaS service, I'm using containers, and so on. And so therefore, you have to understand that you still have to do the security. And I've come to many, one particular client that decided that actually they'd outsource everything, and they'd expect the infrastructure provider still to do the security on their behalf without telling us what to do. So you need to go and take those functional components, decide where they're placed, and then you build up the deployment architecture diagram. And this is a very simple version of it. So we've got a simple view of this architecture. At the top, we've got the connectivity via the internet and via point of presence for private connectivity. Interesting conversation yesterday. I think there was that most of that connectivity via point of presence for WAN is not encrypted, but you know that goes through also. You don't really know where that goes, but that was an interesting statistic yesterday. I think 60% doesn't get protected over that point of presence. And then you know that you're going to do this in the cloud. This is a very simple architecture because it doesn't really contain on-premises, it doesn't contain other clouds. You know that it's in a particular region, you know it's in certain VPCs. So we talk about, within the course and the book, we talk about hub and spoke. We talk about route to live, so it's not the only, it's not just one environment. You're going to have your multiple environments, and then you're going to replicate them depending on with each application, and you end up with potentially thousands of individual VPCs within a cloud infrastructure. But this is a very simple way of doing it. Now, when you really get to it, you get a picture like this, which you're not going to read, but it gives you an idea. At the top, we have a set of actors. Those actors should be the same that you've actually got on your system context diagram. They may not be the same as your on component model, because some of these actors are to do with operations, but you should always make sure that they match up. And down at the bottom is the system. In a hybrid cloud system, your system may actually span multiple clouds on-premise and so on. So that's your system boundary. So that's your deployment model. It looks very much like a cloud architecture diagram. That's because it sort of is. But we've used flat black and white icons that enable you to read it, rather than you have to go and work out the colors to work out what you're trying to process. We try to simplify the diagrams, and also when you're if you try to go and publish in a book, you've got to make it readable on the page of a book as well. So we try to simplify that. Now, to make it a little bit bigger, we considered the case of, in this case of, we discovered that actually we need vulnerability scanning, but we didn't actually have any proxy to enable us to go and do scanning within the cloud infrastructure. So we added that in. But what we have to do is then, for each of those actors along the top, we look at the data flows through the system again and do our threat modeling again, because we're thinking about different threats, because we're thinking about infrastructure rather than application. So we're building up this architecture. So, and I've run through this very quickly, which was amazing. I took some slides out, so which is good, because you can have some questions. So let's have a think about some of the final thoughts. So what have we learned today? So we went through a very basic set of principles that we use in terms of a method to go and architect systems. Architecture today is an art, because everybody does it differently, and that if we're going to architect systems that are more secure, that we can communicate and take less time to do it, then we need to go and have a standard way of thinking about the way that we architect systems. And so what I've tried to do is put together a set of artifacts that enable you to go and communicate the different aspects of an architecture. I went into more detail about the bit about the architecture in the session last year, so go and read that. But when I left last year, I got accosted and people said, well, where can I get more information? And so we'd been doing this for 6-7 years, and I thought, well, what's the best way of bringing this out to the industry and allowing you to go and have access to the information? So I went to O'Reilly and said, can I publish a book? They said yes. So now you can also have this in full, so that you can actually share it within your own organizations. So how can you use that to go and work out where your organizations are? As I say, is your architectural thinking more of an art than engineering? And how can you look at that? Well, I talked about the artifact dependency diagram. Well, you could use that as a heat map to go and say, well, do I do these sorts of things in my own organization? And I think, even do I use architectural thinking? Do I record architectural decisions? Or do I just show a cloud architecture diagram? Do I do threat modeling? Do I do some of the other things in there? So you try and use that as a heat map. Does the ownership of the artifacts extend to the application infrastructure architect? So security security thinking, architectural thinking for security is for all architects. It's not, it's like, you know, if I'm an application architect, I'm looking at resilience. They should be looking at security. So we should be communicating that security is for all architects. The role of a security architect is an SME to go and help and support those application, those infrastructure architects. And secondly, they are really, where we have a specific security application like identity and access management, we own the whole application. We own everything about it, including the resilience, the performance, the availability, all those non-functional requirements. We own all of those as well. So we're not just a security architect, we're an architect. But we're an architect for a specific application. So where does ownership for security reside in your organization? And is there a champion to go and available to go and actually, you know, support and coach and enable your organization? So if you haven't got something like this today, you've now got something written down that you can integrate as you feel fit into your own methods within your own organization. Get some method training. The way we've written what we've done is we've written it as a case study, so you could actually create your own case studies and practice the techniques yourself, and measure over time. Again, go back to the artifact dependency diagram and think about where am I on this journey. So that was the sort of what I wanted to talk about today. And if you want to, the security community, and nobody else's speakers have said it, but a lot of the people that used to exist on Twitter now exist on Mastodon on a server called infosec.exchange. So if you're not part of that community, there's about 20,000 of us in security there. So join that. And has anybody got any questions today? And you can win some socks.
Vertically challenged. Thank you so much. Actually, since no one's asking, I'll ask two questions actually. If
That's
you don't
fine,
mind.
yeah.
So the first question is, you mentioned about the role of the security architect in threat modeling. What about organizations that have both a mature security architecture practice and a mature threat and risk assessment practice? And it's actually the threat and risk assessment team that's accountable for threat modeling. How do you see that?
There are different ways of organizing your organizations. And I don't think that there is it's like all things, there's no right way and no wrong way. If it works for you, then it works for you. But if it doesn't work for you, but I think even all architects, not just this special team on the side, need to be responsible for thinking about threat modeling. Even if they're facilitated through other teams, they're accountable for securing their application. And I think that's getting that mindset that then it's not security's problem, it's their problem. And I think that's the most important thing you can do in your organization.
Thanks very much. And my next question is, for an organization that's achieved the reasonable level of security architecture maturity and is about to embark on the use of enterprise architecture tools to support the practice. I'm talking about tools like LeanIX, Orbis, tools like that. How do you see those benefit organizations, again, assuming that they already have several years of maturity building up to do that?
Again, it's, if they feel their organization is that, I think it's what I've talked about today. I think it will be useful if you go and, yes, your level of maturity you think is great, but there are always areas for improvement. Perhaps by having a look through this, you can actually improve what you've got. And would be delighted if somebody wants to go and tell me, here's a way we can improve what we've got today. So I think it needs to be a conversation in the industry that we haven't been having, because there's nobody's I don't think anybody's, we've had enterprise security architecture, which was 2015, I think it was something like that. But we haven't had anything for solution architecture for security. And I'm hoping this will create a conversation where organizations, we can learn from each other in terms of what we're doing.
Thank you very much.
Thank you.
Is there a core set of what you just discussed that you would recommend organizations leverage when asked to perform a quick review of an architecture for an application that's already designed? Back to, we don't all have a seat at the design table.
When I get asked to sit down and look at an application, my simplest way is to go back to the top level and draw myself a system context. I'll do it myself. And I often find that they don't know what the boundary of the system is to start with. And then I'll go and look at the architecturally significant flows through the system and how they're protecting them, because I'm focusing on the data, not the list, the compliance list that somebody else is, because somebody else is probably doing that. I sit down and work through the flows and discuss working through what controls and how they're protected, and test them on the sorts of the other flows they haven't thought about. And that's the approach I try and take with those sorts of situations.
Thank you.
Thank you.
Thanks very much for the talk. Just one quick question. How would you apply your findings or learnings on vendor procured products? Typically for most companies which are smaller in size, they have a preference to buy versus build. So for products that are bought, how do you apply some of these techniques?
Even if you buy a product, your product has got to connect to something. It's probably got to integrate rather than be standalone. It's got to be managed. It's got to be, you still have some interfaces and you still have some actors. So you can still make use of some of the basic techniques and you will make decisions as you deploy that architecture, that product. And so you can still write those architectural decisions. You can still use some of those techniques. And that's why I say we have this artifact dependency diagram, but you pick off the things that you need depending on the scale of the solution you're trying to put together. Yeah.
And in cases where like the vendor doesn't provide those, is there a way to kind of?
If the vendor doesn't provide those, sometimes you have to dig into the documentation and ask the questions. I've been in the position where, yes, I've had a product, they haven't provided me with the information, so I get their tech sales guy in and I draw the diagram and I ask them, those things, and they often go away and find those things out.
All right, thank you.
30 seconds.
Okay, I'll make it quick. I was just wondering, do you have any thoughts around what, from a governance standpoint, how do you properly govern security architecture and engineering?
So governance comes back to often an architecture board. So it's putting in place gates to, they document stuff. You can't move forward. You can't release stuff into production based on a review. And so, architecture design authorities, architecture design boards, or things like that are part of the overall process. The other thing they're useful for is you'll have issues that across an organization, across a program, so that they can track that. And also you'll have organizational level architectural decisions or principles that the organization should follow as well. So that's also useful as part of the architecture design board. And we finished. Thank you.